Hi everyone and welcome back to my YouTube channel. So today we will be continuing the past papers of physical quantities and units, and the second part was the measurement techniques in which we learned about accuracy, precision, uncertainty. So we will be doing those past papers, okay, those MCQs. So let's start. Okay, so the first MCQ says the student measures time t for a ball from rest. Okay, the vertical distance, knowing that the equation. This is the equation, we know that. The student plots the graph below. Okay, then we have under root h and t. And there's a straight line. Okay, which of the following is explanation for the intercept on the t-axis? Okay, they are talking about this intercept. Okay, first see the first option that says that air resistance has not been taken in account for larger values of h. Um, Okay, first of all, air resistance is irrelevant, okay, in this context. It is irrelevant. No relation in this, okay, through for this graph. Okay. Secondly, that there's a constant delay between starting the timer and releasing the ball. Okay, this would be a option. Okay, let's see the other options. There is an error in the timer that consistently makes it run fast. Okay, if there would be a error in the timer, so we would have a graph like this. Okay, it would be like this graph. Okay, the intercept would have been on the negative axis, not on the positive axis. Okay, so this option is also not correct. The student have plotted h against t square. Okay, so from the equation, if we can see, it is half gt square. Okay, h equal to half gt square, which means it has no intercept. Okay, so the graph would have been like this if the student have plotted h and t square. Okay, because we know y is equal to mx plus c, and there is no c in this graph, no c, so which means that there would not have been any y-intercept. So option B would be your correct answer. Moving to our next MCQ, it's quite easy. Okay, we know the value of G, okay, that is 9.81. The table show the results, okay. What can be said about the experiment? It's very easy. So we know that the values are not a single value is close to 9.81. So this is inaccurate. Okay, the experiment is inaccurate. Okay, let's see about the precision. Okay, precision means that range should become, okay, should be less. So I can see that highest value is this and the lowest is this. Okay, there's an approximately 0.05, okay, range. So it is precise. Okay, so D would be our correct answer. It is not accurate but is precise. Then moving on to our next MCQ, the power loss P in a resistor calculated using the formula. Okay, the uncertainty of V is 3%, uncertainty of R is 2%. What is the uncertainty in P? Okay, so we know that how to find percentage uncertainty, okay, of P. It would be like we have V square, so we can use the power formula. 2 would come here, and it would be like this, multiplied by percentage uncertainty of V plus percentage uncertainty of R. Okay, I have uh, taught this lecture in my previous videos, so do check them out, okay, if you have any confusion. So it would be 3 plus 2, so 8%. These questions are quite easy. Okay, which experimental technique reduces systematic error of the quantity? Okay, so let's check the options. Adjusting an meter, okay, we can adjust, okay, the measuring device. Measuring several internodal distances by mean, they are taking average, like, okay, and you know that average is being taken to reduce which error? Not systematic, random error. Okay, average in repetition is taken to reduce random error. Measuring diameter repeatedly, calculated. This is also for random error. Timing a large number of oscillations to find a period. This is also for random error. So A would be our correct answer. Okay. Student makes measurement from which she calculates the speed of sound is this. She estimates that her result is accurate to 3% plus minus 3%. Which of the following gives her result expressed to appropriate number of significant figures? Okay, so we can say that it would be like 3% of 330 is like 10. Okay, so her answer would be accurate. So her answer would be 330. Okay, because you know the 3% of 330 is 10. Okay, and her answer is like 326.66. So we can consider it to how many? Two significant figures. Okay, so that would be rounded off to 330. Then we have this component. Okay, so we have studied the component. Okay, but this is a sort of kinematic question, so I won't be going into that detail. Okay, leave this question. We will do that again. Okay, in our next videos. Okay, then let's continue with our next MCQ, which is quite interesting. Okay, student measure graph of x. Okay, no need to go into the details. Okay, just let's read this one. Which graph could be obtained if the measurement of x has a large systematic error but a small random error? Okay, so large systematic error means what? Okay, I have told in the previous videos the large systematic error means that the measurement, the experiment is less accurate. Okay, and small random error means that random error is small, that is the experiment or the measurement is more precise. Okay, so you need to remember these relations. Okay, how we can see that the experiment measurement is less accurate through the graph? That it should not be on the true value. Okay, the peak should not be on the true value. So A would not be correct, B would also be not correct. Okay, now we need to see between C and D. So more precise is, means that the range should be less. Okay, so from C and D, only C has a less range and it is not above the true value, which means C would be our correct answer. Okay, then we have this. Okay, it is a length of bar whose true length is this. Okay, 895 millimeter. Repeated measurements have been taken. Are the readings accurate and precise to within 1 millimeter? Okay, now we need to see results are accurate within 1 millimeter. No. Okay, because 892 is the highest value and our true value is 895. Okay, so we can say there is a difference of 3 around millimeter. It is not within 1 millimeter. Okay, so no and no. Results are precise within 1 millimeter. Yes, we can see that there's 892 and 891 value only. Okay, and that is, so we have values between 891 to 892. That is a difference of 1 millimeter. So we can say that we have precision of 1 millimeter. Okay, yes. So B would be our correct answer. Okay, so now this MCQ. Thermometer can read to an accuracy of 0.5, okay, degree Celsius. This thermometer is used to measure temperature rise from 40 to 100. What is the percentage uncertainty in the thermometer of the temperature rise? So you know that how we can calculate temperature rise? T final minus T initial. Okay, So T final is 100 minus initial, that would result in 60 degrees Celsius. On the other hand, if you need to find the uncertainty in temperature change or temperature rise, that would be adding the both uncertainty. So temperature final also have 0.5 as well as temperature initial have 0.5. Okay, we will be adding the both uncertainty. You should remember that uncertainties are always added. They are never subtracted. Okay, this would be your uncertainty of temperature rise. Now you need to find the percentage uncertainty. What we will do, we will use a formula that is delta T upon T multiply by 100%. Okay, so 1 upon 60 multiply by 100% and you would get your answer. Okay, so this is how you're gonna do the question. Then we have already did this milliampere question in our previous video. Okay, so do check that out. In experiment, okay, now let's do this question. In an experiment, a radio control car takes this, okay, seconds to travel this distance. What is the car's average speed and uncertainty in this value? So we know the speed formula is what? Distance upon time. First, we will calculate the speed, that is 40 by 2.5, that is 16. Okay, then we have our uncertainty. Okay, so let's see. Uncertainty would be how we calculated delta D plus delta T. Okay, and there will be the fractional uncertainty because the quantities are being divided. Okay, so that would be around 0.36. Okay, now we need to, okay, we know that these options are incorrect. Okay, now we need to analyze that whether C would be a correct answer or D. So always remember that uncertainties are always to one decimal places. Okay, there is always one decimal places, or you can say one significant figure. There always one significant figure or one decimal places. So D would be your correct answer because D in D the uncertainty is to two decimal places. That is not correct. Okay. And we have our next MCQ. The resistor R of unknown resistive form equation potential reference. Okay, current. We know this formula. We have studied in this our O levels. The voltmeter reading has uncertainty this, and ammeter has reading has an uncertainty 2%. What is the uncertainty calculated? It's very simple. How we calculate percentage uncertainty is like percentage V plus percentage uncertainty of I. That will be 3 plus 2 equal to 5. Okay, C would be your correct answer. Okay, so these are the values of G. Okay, which student obtain a set of results that could be described as precise but not accurate? Okay, precise means less range. Okay, the value should be close, and accurate means not accurate means, okay, it is not accurate means not close to 9.81. Okay, for the value G. So in first row we can see that the values are not close to they are, okay, some of them are close in this one also. Okay, okay, we can consider this option and we can consider this option. Now we need to see which one is more precise. Okay, that would be your correct answer. So more precise is D. Okay, C has a greater range as compared to D. So D would be your correct answer. So you need to analyze each and every options very carefully. Next MCQ is this. Okay, we have been given the quantities. These are the quantities: mass, acceleration. This is distance. This is time. The power used. Okay. in the accelerating, the mass is equal to product of force and velocity. Okay, power is equal to force into velocity. Okay, so we need to find a percentage uncertainty in power. Okay, so we know that F is what? MA. Okay, we have already studied. And V is what? Distance upon time. So distance upon time. So this could be our formula. We need to just add the percentage uncertainty. It is as simple as that. Okay, so percent plus M plus A plus S plus T. We just need to do this, nothing else. The 0.1 into 1 into 1.5 into 0.5. So this would be around, if you see 2, 3, 3.1. 3.1 would be our correct answer. Okay. MCQ 5. The measurement physics may be subject to random errors and a systematic. Okay. Which statement is correct? Random errors can be reduced by taking average. Okay, this is correct. Random are always caused by person taking. No, they are not always caused. Systematic error cannot be. Okay. Systematic is a different reading each time the measurement is taken. No, that is due to the random error. Okay. So A would be simply your correct answer. Moving on to this MCQ, the last MCQ which states that current in wire and potential. They are calculated in resistance. Okay, that is V over I. So delta R upon R would be equal to delta V upon V plus delta I upon I. Okay, first we will calculate R. What is R? We have been given the current and potential difference 8 upon 1, 8. Okay, insert that value here and their respective values here. Okay, then calculate the uncertainty. Then you will get your final answer. Okay, always remember that uncertainty is always to one significant figure. So the answer will be from this one or this one. Okay, so these were the MCQs of measurement techniques. Okay, there are a lot of MCQs. If you want me to make another video of the further MCQs, do let me know. Okay, see you in the next video from where we will start our kinematics topic.